Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Spot.io. My name is Cody, and welcome back to Techstrong Learning. Before we dive in, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you miss any of our conversation, if you'd like to watch again at a later time, or if you'd like to share this with the rest of your team, we will be sending you an email with access to the recording shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining us today. If you have specific questions throughout our program, we do want you to submit those to that Q&A tab on the right side of that chat section. If you do send in your questions to the chat and you happen to see them disappear, worry not, I'm just moving those over to the Q&A so that our speakers can better keep track. Additionally, if you jump to that handout section, you'll see there are a couple of resources there for you, as well as one that I'm going to pin to the top right now that is called Spot Labs. I believe you will need this link in order to follow along with our workshop today, so do feel free to click on that before we get started. And finally, before we close things out today, or rather after we close things out today, I will be selecting two of our most engaged attendees to win a $50 Amazon gift card. So ways to become eligible are to send in chats, send in questions, and to fill out our post-webinar survey. That is in the handouts, but we'll also post that in the chat toward the end of our session, and I'll remind you then as well. So let's dive right into our virtual workshop. Our topic today is optimizing Kubernetes in the cloud the smart way. I'm joined today by Jeff Welch, Cloud Solution Architect at Spot by NetApp. And we're also joined today by Siley Moore, Cloud Solutions Architect at Spot by NetApp as well. So Jeff and Siley, thank you both so much for joining us today here on Techstrong Learning. Jeff, would you like to take it away from here?
Yeah, thanks, Cody. Appreciate the intro and appreciate everyone joining. I'll be kind of running the workshop today, and Siley's going to be, I guess, the moderator and answering questions where possible, and otherwise we can bring them up into the conversation. So yeah, please feel free to be active and ask questions. I'm not going to spend much time at all on any marketing, but I do want to set the stage on what we mean when we say optimizing Kubernetes the smart way. So, as you may or may not know, Spot is a platform with a variety of solutions. Today, we're talking specifically about Ocean, which is specific to Kubernetes, whether it's EKS, AKS, GKE, it could be COPS, really any Kubernetes flavor in the public cloud we can support. And really the main point of Ocean and really our entire platform, I'm going to spell it out in 3 slides and then we'll just jump right into the workshop. So I think we can all agree the reason a lot of people go to the cloud is, things are easier. Sometimes they're cheaper when you first start out, and it's just really easy to scale. But then you quickly realize as you scale, some things change. It typically gets more complicated, and it typically gets more expensive and harder to track those expenses, right? So leads to a couple things. You can either kind of invest a lot more money and maintain the simplicity, or the flip side is you can, make it much more complex to lower the cost. And really what our platform is intended to do is provide the tools that's going to restore the order. In other words, kind of bring you both simplicity and cost efficiency. And that's what brings us to Ocean today, specific to Kubernetes. I think what we just talked about, the kind of the progression of moving into the public cloud is very, very applicable to Kubernetes, right? You kind of on-prem, it's pretty straightforward. You have some servers and the costs don't really fluctuate. If you need more servers, you buy them and they're always there. But when you get to the cloud, a lot of times people push the easy button and they tend to over provision, more more instances or more VMs than they need, or more powerful instances or VMs. What Ocean brings to the table is really three kind of main pillars. The first one is dynamically provisioning infrastructure based on your specific workload and kind of basing that on availability and pricing, right? So instead of kind of statically scaling with a single instance type with no real awareness to the relative cost or availability, that's where many or most customers tend to end up. Really, that's the easy button, but it tends to be expensive. The next thing we do with Ocean is bring this notion of true pod-driven auto-scaling. And what I mean by that is awareness of the pod requirements, or requests, and how they would fit into a variety of instance types. And then we combine that with advanced bin packing, which means continuously looking at the cluster to see, is there a better makeup of instances that would serve this workload, both from, again, an availability and a cost standpoint. And then the third thing, kind of bringing it up a level from the infrastructure, we're actually continuously right-sizing the pods. For example, a request size could be, 1 gig per pod and 512 meg of memory. But in reality, that pod is only using maybe a half of a vCPU and 256 meg of memory. We can actually dynamically change that request size, with parameters that you provide. So that way you're not, you're creating efficiency at the pod level as well as the infrastructure level. And then finally, we're presenting some unique visibility around costs and performance that we'll look at in the workshop. So that's really kind of setting the stage for the value that Ocean brings to the table. A lot of people, the top of mind is cost, and that's certainly a prime piece of what Ocean does. But there's so much more as far as, being much more efficient in a variety of dimensions, which we'll get into today. So I'll jump right in. The first place I wanted to take you guys, and this is the link that I think Cody shared in the handouts. We kind of changed it. Hopefully it didn't cause any heartache for anyone, but this particular site, labs.spot.io, is a very valuable site. It's got a lot of workshops you can go through, whether it's EKS, AKS, GKE. We've even got some things around Spark and Elastigroup, some of our other solutions. But it goes pretty deep into using infrastructure as code, Terraform, which is, certainly a valuable thing. But in the context of this workshop, an hour simply wasn't enough time. So what we settled on was, the real prerequisite, if you want to join along with the workshop, is simply having some managed Kubernetes cluster, typically EKS, AKS, or GKE, and then a Spot account set up, right? So assuming, a large portion of the audience has that, we can jump right in. But we won't be following along specifically with this lab, but I encourage you to go back to it because there's quite a few additional components you can work with, Grafana and Prometheus. You can get deep into headroom. We have specifics for Azure and GCP. Today, I'll be working with EKS specifically, but we've got detail on those as well. And by the way, what I'm doing today, if you are on, GKE or AKS, you should be able to follow along. There's not a huge difference. But having said that, I'll jump right in. So I'm setting the stage. I have a basic cluster in EKS, just 3 nodes, a standard node group, nothing unique about this cluster. I happen to have a deployment with 50 just Nginx pods running, just in order to put some workload on the cluster. So that's kind of the first prereq. And then I do have a Spot organization. We call it an organization because accounts actually mean mapping to your cloud account. So assuming you have a spot organization, and if you don't, you can simply go to console.spotinst.com. Siley, I don't know, maybe you can put that in the chat just in case.
Yep.
And from there, you can follow along and either create your org, or if you already have one, we are going to connect in my case, my AWS account, my linked account, to my spot organization. I've already got a couple of accounts connected, but I need to connect my production account. So pretty straightforward. I'm just going to call it JW prod, create the account. Clearly, I'm going to go with AWS. And I'm working with a linked account. We've got other solutions that do some pretty unique things with the management account, working with billing and such. But for today, we're working with a linked account. And again, we have some options here. I'm going to use a cloud formation stack. We can do it manually as well. Some customers like to do this to see specifically what's happening, but you'll see very quickly, all we're doing is creating a cloud formation stack that creates a role and a policy that we attach to that role that allows us to assume the role and operate in your account. And we'll get a bit more into exactly what we're doing there, but for now, we can say, no, I'm not doing anything in GovCloud or China. And this is just saying, hey, let's validate you're logged into the correct AWS account. I am. So I'll go back to the console. Next. And I'm going to go with default permissions. If you hit customize, if I'm not using some of my other solutions, I can clear those off, and it's going to, in turn, take off these permissions. I'll just go back and make it default. And now I'm going to run my template. It's going to open my AWS account into CloudFormation. I can look through here if you'd like. You can look at the template, just grab this URL and paste it into your browser. You can look at the policy that's going to be applied. Pretty straightforward. And then I'll create the stack. Take about 2 minutes while we're doing that. I'll kind of chat a bit about what's happening. So again, we're operating in your account. Sometimes questions come up whether these VMs or instances are being launched in our account or somewhere else. But no, they're actually just like a typical EKS cluster. We're simply calling the AWS API on your behalf based on your workloads. So you have complete control, from a policy standpoint, from a security standpoint, to have observability to what we're doing in your account on your behalf. So pretty straightforward. And I'll talk at the end about how we can do an analysis to see the potential benefits in your account. And that would be done in a similar way that you're seeing here, but with a read-only policy, as opposed to a policy that allows us to actually operate in your account. So let's see. Looks like. So now if I go back here and I can go to my settings, I'm going to look at my accounts. And it looks like that prod account is connected, right? So now I'm going to see that prod account is now available. I will go into the Ocean section of our console. Again, highlighting, the Spot platform is a group of solutions. We're going specifically to Ocean today. But, if it's of interest, we could certainly dive deeper into some of the other solutions. So I have no clusters imported currently. So clearly the first step is going to be looking into our AWS account and importing that EKS cluster that I showed earlier. It happens to be called Jeffy. I had some other names, but I had to give it some unique names, so I went with Jeffy. If you're on AKS or GKE, you'll see a bit different here, but similar process. We can even create a new cluster from here. So from the Ocean console, I could actually create an EKS cluster directly from here. So it kind of minimizes having to go back and forth, but we're working with an existing cluster. So I'll go there, and then it's going to, I happen to be in US West 2. Now it's going to look for the clusters. I happen to have only one in this particular account. So I'll select it. I could give it a different name in my account if I'd like to. I'll keep it the same. And then I happen to have only one node group, but if I had multiple node groups, which is pretty typical in production environments, I would select one that would be kind of my default template, that as we move forward, some settings would be based on that just as a template version. But since I only have one, that's what I'm going to populate it with. You'll notice a lot of this probably is familiar. It's simply importing the configuration information that is found in EKS, right? Everything would be exactly how your cluster is configured. You could make changes here if for some reason you wanted to. You'll notice we even have the user data, which you can edit. We'll go into that. I'll do that after I finish the import. There's some things that we want to do there, but you have complete control. So just to be clear, we're simply importing the configuration so that we're able to launch instances into your cluster with all of the configuration information that was already there. We're just going to do it in a much more intelligent way, as you'll see. Here's where we have to make some choices. So one of the values of Ocean is our ability to not leverage a single instance type, but leverage a wide variety that leads to much more efficiency, right? So in this particular cluster, we can see if I go to compute, go to my node group, I simply am using a single instance type, an M5 large, which is very common. That tends to lead to extreme inefficiency because you can only scale in certain basic block sizes. With Ocean, we're going to be able to look at a large number. I'm going to go ahead and go to manual selection just to illustrate the sheer number of instance types that are available in AWS today. There's 765. And you can imagine with all the different availability zones that these instances are in, there's just a wide variety of cost and availability and performance that any customer couldn't be expected to have a grasp of. That's specifically what we do. So I'm going to say, you know what? I'm going to make it very simple just for our workshop. I want to work with I'm just going to do some T3 mediums and larges. I'll grab some C5 large and just keep it real simple just for illustration. And then we go down and by the way, you can also select based on, you can select based on, we can filter based on vCPU, memory, GPU. Perhaps you don't want to run GPU. You can exclude those. You can exclude certain families. So I don't particularly like Graviton for some reason. Unusual. Most people are liking Graviton these days, but you can kind of filter on many attributes. But we'll stick with that manual and go with the few. I selected just 3 just for our purposes. And then we're going to import, of course, the tags so we don't break anything in your environment. You can clearly add tags here as well. Key pairs, if you're doing anything with load balancers, any of those things are available here. And then if we had additional node groups, this is where I could also import those, right? So moving forward, once you start operating in Ocean, this can all be configured directly in Ocean. You don't need to go back and forth between Ocean and your EKS console. You can do it all here. So moving forward, the next spot, we need to get a little bit into how Ocean works. And really the only thing we deploy into your infrastructure is a single pod that we call the Ocean controller. It simply takes information from the control plane, things like pending pods, where particular pods are currently running, memory, all the metrics, all those type of things. We we pull those from the control plane and then we send them back to our SaaS backend. And that's what allows us to make intelligent decisions on when and how to scale. And in order to do that, we need to create a token. And this token is on our platform. So I'll just do it. You can do it from here. I'll just call it Jeff token 2. And it simply allows this pod that we're going to deploy into your cluster, it allows it to communicate back to the Spot back end. And this is where we're going to install a controller. And a couple options here. Really, the only one that concerns us today is I actually do want to install the network client. It gives added visibility into network costs. So I checked that box, and you'll see down here, it just moved this from false to true. And then I simply copy this, and I am going to go into, let's see, hopefully we get this. So I'm just going to drop this into my console. And if you look at this, it's just going to pull basically an image and pass some variables and deploy a pod into my cluster. Whoops. Can I use, oh, I deployed this earlier. So I am going to go back and rename this from Jeffy to Jeffy 2 or something. Let's try that again. Whoops. What do we have going here? Apologies. Oh. Cannot reuse a name still in use. Siley, can you help me? A spot already exists with the same configuration. What spot already exists with the same configuration?
Do you have a controller running in Jeffy 1?
No, I deleted
The deployment?
Nope, looks like we're good now. Let's see. Let me go into, for simplicity's sake, I am going to go into Lens and take a look at what. So if I go to pods, so I do have a controller running now. So we're all set. So go back to that installation screen. And now I can test connectivity. So I want to, well, that's not what I had hoped for. Did I change the cluster name? Spot account, Jeffy 2. So I'm going to kill this and redeploy. And make sure the deployment itself is gone. And let's do that again. And now let's see if we have it. There we go. There we go. Apologies for that. So now the controller is able to communicate with our backend successfully. That was a relic from testing the environment earlier. There was a controller that had the same name that was running on our platform. So wouldn't happen for you guys, but just a relic of setting up for the lab. So moving forward, now we get this kind of summary of the cluster. So we've got the cluster configuration ready to go. We've got the controller deployed. And now I can create the cluster. So the cluster, when we say create, it's actually bringing that configuration onto the Spot platform. And now you will notice it can see the 3 nodes, none of which are managed by Ocean. But you'll be able to see some of the things that we'll be working with shortly. So typically at this point, the question is, well, what do I have here? Well, what you've got is an Ocean cluster with a configuration of that particular node group waiting to scale. And the way we would scale is going into EKS and either disabling the autoscaler and scaling down, or we actually have a GUI-driven workload migration tool. It's a great tool. It is very conservative and deliberate. So for the purposes of our lab, we're going to kind of go the forceful way and go in and actually start scaling down in EKS. You'll see there's no nodes. We launched one node. I'm going to launch another one in order for the workload to have somewhere to go when we start scaling down on the EKS side. So you'll see once I do this, I should have 2 nodes running. I'm going to wait until they are actually joined to the cluster. So this one's actually healthy on the Kubernetes side. So what I can do is I'm going to go into my node group, and I'm going to just scale it down to 1 node for now. Just so we have a little margin of safety. And then we'll see those eventually go down. And you'll also see the additional ones that we just launched a few seconds ago. And once these are done, going back to the Spot console, let's see. So this one, status is still healthy. It has 1 node there. And let's see where those pods are. So we've now got 2 nodes. And those pods have started to move over. Let's go look at Lens and see what is going on with all the pods. My guess is there's some... Nope, none are pending because there's still 3 nodes up and running. 1 still managed by EKS, and 2 managed by Ocean. So now we're going to go back to EKS, and oops, there we go. And I'm going to scale this one down to 0, which means Ocean is going to scale up automatically at this point to manage all of those pods. And then we'll see. So we should see it when those pods become pending. We'll look at the log. And let's see if these nodes should be going away shortly. Yep, that one's going away. So now going into the console, we should see another pod launch, another node launch shortly to cover. Although it did launch C5 larges, so my 50 pods are covered by these 2 instances, so we likely won't scale anymore. I'm going to quickly scale this deployment.
So Jeff, there is a question. It's okay.
Yeah, please.
So during the import, they're asking where do these workloads reside? Is it on the ocean side?
Good question. So during the import, everything is still residing in your existing EKS cluster just the way it is. After the import, typically the only thing that happens is we launch a single node, but we don't proactively disable anything on the EKS side. So at this point, you're somewhat in a state where you've got, if you have auto scaling enabled on the EKS side, you're in a state where you've basically got two auto scalers operating. So you kind of need to make a decision to either, stop Ocean from auto scaling. You can disable scaling right here for Ocean if you just kind of want to get to this initial state and make sure things are, the way you like. Or more traditionally, you go into EKS or, again, AKS, GKE, and you disable scaling there, and then you scale down. So to answer the question on import, really nothing has been changed in the EKS. So all that workload is still running on EKS managed nodes. So you noticed we can look at the log and we can see that instances were launched, right? So we realized there were pods unscheduled, and we can look and see the decision that was made. So we model what needs to be launched. Well, in advance of scaling, we had, 3.86 vCPU. Here's what we would have. Same with memory. So we actually scale based on the requirements, and we can get so here are the standalone pods that were there. So this node exporter, I had this NGX. We had two of those pods, and they required, a certain amount of memory. So we're going to choose the right instance type when we need to scale, right? So now going back to those nodes, pods are starting to be scheduled onto them. And then over time, we'll continuously look at the makeup. In other words, if I change the deployment, I actually bumped it up from 50 to 75 in order to show some scaling. If I, at the end of the day, your pods scaled down to 20 perhaps, we'll see this cluster change its makeup. A different machine type, fewer machines, whatever it might be, in order to be the most efficient possible, right? So some of the things that customers typically do after they kind of move their workload to Ocean, they might create another virtual node group. And think of this as a layer of abstraction, much more powerful than like a node group or node pool on the hyperscaler. So if I create a VNG, I'm going to configure it manually. I'm not importing it. If you had a node group, you could import it. I'll configure it manually. And then it will take the images, defaults from the original node group that was imported. So I'll simply, let it use these and take it from the template. But this one, I want to run only GPUs. I have a workload that is GPU intensive, right? So I'm going to select GPU, whoops, and let's see, whoops, and I want, why can't I, there we go. So, I don't have the AMI is not GPU compliant. So I'll just make this one a, no GPU. I'm going to make it just general. This will be all, what? Why is it? Okay. I'm not sure. Let's Start over. So I'll create another VNG manually and take that VNG, take that template, no node labels, and I will allow this one to be automatic. But the thing I'll change, instead of changing the instance type, I want this one to only be on demand. So one of the values, clearly based on our name, Spot, is that we can leverage Spot instances or Spot VMs in a way that the hyperscalers natively don't offer, right? So we can look at all of the different instance types, the different AZs, and we have years of historical data and current real-time data that gives us a Spot score. So we can very intelligently select Spot instances in all the different markets that you allow us to look at. And what that leads to is very, very reliable Spot instances at a very, very low cost. So traditionally, customers sometimes in production shy away from Spot instances because they have a reputation for being terminated unexpectedly. You know, that's the very nature of a Spot instance. 2 minutes is the SLA on AWS. AKS and GKE have different termination SLAs. We tend to make that a bit different in that 85% of the time, we can predict an hour in advance when a Spot instance will be terminated, which leads to the ability for us to proactively replace instances before they're terminated. So Kubernetes is a perfect use case for that. As you scale, just the very nature of Kubernetes, you're constantly replacing machine types. So many customers use Spot instances exclusively in Kubernetes, but there are workloads where even a single termination could cause issues. A lot of times customers that are running long-running jobs that if they're terminated cause problems, they might want to run on demand. So we can say instead of running 100% Spot, we could say, 50% Spot, or in our case, 0% Spot, which means everything will be on demand. Your traditional, fully available instance type that you pay full price. Maybe you have commitments to lower the cost, but so we're going to create a VNG that is 100% on demand, which is the change I just made there. And clearly here you can, let's say we always want 2 nodes running. So by default, we could scale to 0 nodes if there's no workload, but we always want 2 nodes running. And then one other thing I'd like to illustrate is this notion of headroom, right? So in a traditional EKS or any Kubernetes cluster, it's somewhat a just-in-time scaling methodology where the cluster is running close to capacity, ideally. Oftentimes, it's actually over-provisioned, but in our case, we're going to try to run very efficiently, 95% CPU utilization. But some workloads require additional capacity to be available instantly. Perhaps your application behaves in such a way that if it needs to wait for a pod to scale, it breaks the application, or you'd like to offer a better experience to your customers. You can actually create manual headroom, and I'm going to show you automatic headroom as well. So you can say, I always want, a certain amount of vCPU running, or I always want a certain amount of extra memory running. So you can configure that here. You can configure it in different ways. This is all configured. You could schedule this. So every morning at 8 o'clock, your cluster adds 20% headroom. And then at 5 o'clock, you take that 20% away so you run more efficiently, right? So for our purposes, I'll leave it there. And in a second, I'm going to show you automatic headroom. So now I've got 2 virtual node groups. And then in order to schedule pods into these node groups, I would use labels or, affinity or node selectors or whatever method you would typically use to schedule pods to particular node groups or node pools. We follow that same methodology, right? And moving forward to kind of round out the headroom. So by default, we provide 5% headroom. So just broad 5% across the entire cluster. We'll always have that available. But here's where, in the morning, and again, this is schedulable via the API, or, we can do it. We have a schedule cron job, but I want there to be 20% headroom. This is where I can affect that change, right? And we looked at manuals already, but this is where I would do 20% headroom and then save that. So now my cluster will always have 20% of available. And once that's filled up, we'll scale again to have yet another 20%. So you're paying a bit more, but you've got an always available amount of resources. And then what else did we want to look at? So that's, one more thing. Let's go back to that user data. So again, we give you control over all the same things, but one thing that brings up a great feature of Ocean, we want to take out this max pods number. So this was imported from that original node group. Remember, it had the M5 large. If anyone is familiar, in all three hyperscalers have this notion of max pods. That's actually based on typically the amount of IP addresses available on a particular instance. It just so happens an M5 large has enough ENIs to support 29 pods. The problem with leaving this here is that any other instance type we launch will inherit this value because it's hard coded into the user data. So, and you can think if we launch a T3 large, it's going to be, I believe, 17 is the max pods. Clearly a C6 extra large is going to be more than 29. So we would simply take this out. And then one more thing, we would say use max pods equals true, because EC2 actually, or EKS actually calculates this automatically in the image. So EKS optimized images calculate the max pods automatically for you. So that's just an illustration of when you might want to change this user data, which we clearly fully support. So it's going to ask me, do I want to roll my cluster? And that brings up another interesting feature that we have. And I will illustrate that here. So a couple times you might want to roll a cluster. What we did just there, we changed the configuration. Perhaps I created a new security group or added another AZ. I may want to basically refresh all the nodes in my Kubernetes cluster. We can automate that for you. And we can do a batch size percentage, right? I can go to half of the batch at once, whatever it might be. And then I need to see a certain percentage healthy before I continue the roll, right? So we can get very, very specific how we want to do that. I'm not going to do it here, but the other place that we use that cluster roll is with automatic AMI updates. So imagine a scenario where you are on Kubernetes 129. I believe this cluster is on 129. Yep. And I believe today or yesterday, Kubernetes 1.3.0 came out, kind of a major release, but even minor releases, we actually support automatically updating the AMI once we see the cluster is upgraded. In other words, if you go in here and you upgrade the cluster, so upgrade insights, this happens to have a new AMI, I believe. But if you see an option to go to a higher version of Kubernetes, we actually recognize that. We'll update the AMI automatically in the VNG. So in other words, we'll find the correct new AMI for the version of Kubernetes you're on, EKS, and we will schedule or immediately execute a cluster role. So you don't need to go in, you can imagine if you have 50 nodes, managing that could get fairly difficult. We actually can manage that for you, right? So just a little bit more value on top of simply kind of doing that on your own, right? And I'm going to discard those changes. And you see we've scaled up. And as time goes on, you're going to see this scale down. Maybe by the end of the call, we launched 2 on-demands because I created 2 minimum nodes. And these are already at max pods. So this won't scale down quite yet, but we can probably make a change and see some scale down behavior. Next thing I wanted to look at was we talked about visibility. So at the beginning, I talked about, there's nothing imported yet. I can go look at it. I'll go look at another section. So in a fresh cluster, we don't have the data yet, but I have another demo environment that I'll pull up. Oops. And so I'll go back into Ocean, look at my clusters. And if I go to, let's see, I'll go to US West 2. And if I go to my cost analysis, I'm going to see a few things. First one is compute cost, storage cost, and network cost. So network cost at the beginning, when I deployed that controller, I checked that box that said I'd like to deploy the network client. That's a daemon set that attaches obviously to each node, and it allows us to see all of the network traffic and categorize it. So by namespace or by pod, or deployment, we can actually see and break out the cost for each component, right? And we can report on that. So whatever it might be, reporting, show back, cost back, we can actually break that down for you. These numbers sometimes natively in the hyperscaler are somewhat difficult to bring together unless you've got a pretty rich tagging strategy. We kind of do it for you automatically. And if you look at the network costs, a place where people sometimes don't realize how much they're spending in Kubernetes, especially when you're accessing services and different AZs and such, we actually break that down for you. So you can see there's 4 different network costs to be concerned with: intra-AZ, inter-AZ, inter-region, and internet. So we break the specific cost down for your environment. You can see this particular customer has spent, a significant amount, relatively speaking, $416 in inter-AZ traffic, right? So that might be something they can change their topology to reduce that cost, right? 3.34 terabytes inter-AZ. That's maybe something that could significantly reduce costs. So we deployed that in our cluster. It takes, I think, 30 to 45 minutes for those costs to start coming in. But you can kind of model those in a variety of ways. You can export it clearly. You can see, by, how much does headroom cost to me, right? You can break it down by day and month and see a variety of things. And like we talked about, you can actually use labels here as well and work with the dates. Another feature that I'm going to configure, well, let me go back to my demo environment and get back to JW Prod and Ocean. So here's my cluster. This is a demo environment for me. So I really don't want this cluster running 24 hours a day. So I am going to go into this customized scaling. This is where we did headroom, but I'm going to enable shutdown hours. right? In other words, I want this cluster to completely shut down, every node terminated. I'm going to just select everything, and I'm going to say I only want it running, let's say Monday through Friday, Monday till 6, Tuesday till 6, and Thursday till 6. Is today? Yeah, today's in there. I don't want it to shut down on me. Yeah, so if I save this, what'll happen is at 7 o'clock today, this cluster is going to completely shut down, and it will spin up automatically. Apologies. It'll spin up automatically when those shutdown hours are over. So in our case, it would spin back up, not until Monday. I want it to spin up tomorrow. So let me save that. So now I've just done something that would have to be done manually in a traditional EKS or Kubernetes environment. We've automated that to, again, save money, be much more efficient. And then I believe, silently, I believe we've covered, oh, last piece, apologies. Great, relatively new enhancement to this feature. And same thing, I'm going to have to go to the other, apologies. This takes a bit to also takes 45 minutes to populate the right sizing as well. I mentioned this at the beginning. We actually look at the request sizes that are provided in each pod, and we can see what the actual pods are using, right? So in this case, overall, all the cluster resources, this is how much has been requested. So your DevOps guys, whoever's building these deployments, they put a request size for vCPU and memory. And if you think about it, of course, they're going to kind of request more than they need in order to, maintain performance for their application. Sometimes it's pretty significantly different. In this case, you can see around 200 vCPU. In reality, it's only, we're saying recommend 44 vCPU. Same with memory, 250, 230 gig of memory. We're actually recommending only 56 based on what's being used. And we can actually automatically make that change for you, right? So some customers want that to happen. Some customers want to go back into the pipeline and make the change in code. We can actually do it dynamically, so we can be even more efficient. So as we look at the request size, they're more in line with what the application truly requires, which is going to make you run on even more efficient infrastructure. And then you can go down here, and here are the actual recommendations. So if I look at this first one, he's requested 4 vCPU. He only needs 0.189, so significantly different. And we can actually dig a layer deeper and see how much vCPU, let's just look over the last 6 hours, how much has actually been utilized by this container. So, memory populated first. We'll look at memory. So that's the actual limit. Here's what was requested. Here's what was suggested. And here's what was actually used. So you can be confident because we present the actual utilization, and we're recommending a bit more than utilization, of course, for some headroom, but significantly less than what was requested. So you can do that for each of your deployments and pods. Same thing with vCPU. Here's the limit. Here's what was requested, and literally hardly anything is being used. So it gives a lot of insight. We can export this. Again, we can automatically enact these changes, but just gives a lot of visibility, even above the infrastructure layer, which leads to much more efficient infrastructure. And at the end of the day, the idea is that we're going to be running these nodes at a very efficient percentage. You see this particular cluster is running very efficiently. It's got CPU all above 90%. And we're running a variety of instance types because when we wanted to scale, we picked the best one at that point in time. So we went through a lot today. Hopefully there was some clarity on how Ocean can help you run a smarter Kubernetes cluster and take some of this manual work. If you're even considering this manual work, take some of it off your plate and let it become automated. I'll pause there. Siley, any additional questions in the Q&A or?
I answered most of it. The one I'm answering now, the question is regarding the scaling aspect for Ocean. What additional criteria does Ocean look for on top of what Kubernetes provides?
So we don't replace the scheduler. You can think of at the most basic layer, we replace the autoscaler. So we look at the same things an autoscaler would, but we take it a level deeper and actually look at running deployments and pods to understand if we can more intelligently place those elsewhere. So if let's look at the overview. So this one, we can see, and I'll answer that question specifically by showing you something. But so this one, we have saved 57% of the cost of this cluster by running on Spot. So that's easy to look at. It's clearly cheaper to run Spot instances. But we can also say we have scaled down 9,000 nodes by bin packing. And bin packing is what I just described. Looking at the existing makeup of the cluster, which is something that the native autoscaler doesn't do. It simply looks at unscheduled pods and scales, and it looks at underutilized nodes and scales down. We actually look at every 30 seconds, look at the makeup of the cluster and compare that to the current cost and availability of instances. And if there's a more optimal makeup, in other words, let's say you're running at 10 C5 larges, and that costs you $100. Could we run at 20 C5 mediums, and it happens to be cheaper? We will make that change progressively, right? It's not instant, right? But we'll change that cluster to adapt to the cost and availability structure at any point in time. And the third thing we do, we can revert to lower cost. So I kind of mentioned that a cheaper node becomes available. Or let's say when we went to launch an instance and you wanted us to choose a Spot instance, maybe Spot instance wasn't available. For whatever reason, the market was busy. It wasn't available. But let's say an hour later, again, every 30 seconds we're looking, maybe an hour later, a Spot instance did become available and we felt it was going to be available for a long time. We can actually revert to that lower cost instance again to run a more efficient and lower cost cluster. So, from a decision standpoint and what we're looking at, I would just say we're taking all of these metrics and doing many more intelligent decisions based on what's there, as opposed to simply looking at, are there unscheduled pods I need to scale up for? Or are there underutilized servers that I should scale down for? Because that's really what the cluster autoscaler does. We're simply much more intelligent than that. Yeah. And then with just 2 minutes left, the last thing I'd like to share as kind of a takeaway, we have this ability I mentioned at the beginning when we were connecting my AWS account. We talked about the policy, and I mentioned that we can actually do that same connection, but use only a read-only policy into AWS or GCP or Azure. And it's going to look at your infrastructure, what you have running today. Do we have Ocean in this one? Nope, it's fine. We have Elastigroup. So it's going to look at your infrastructure and break it down by cluster or auto scaling group or load balancer or whatever service you're using where these instances are running. We're going to analyze those over time, and we can present back to you if it runs on our platform, right? We're going to make it easier to run. We're going to make it much more efficient, but we're also going to save dollars. And we can actually show you an estimate of how much can be saved per cluster, per auto scaling group. And then we summarize it, of course. So now you can kind of look and see, is there a good use case? Is there a good cluster where I could see some significant savings and enjoy the benefits of this kind of enhanced automatic scaling and bin packing and all the visibility we shared today? So we make it very easy for you to get this analysis completed. Clearly, no cost associated with that. You simply make the connection. A couple of days later, we get back together and we go over those things. And hopefully, we see something that makes sense, and we can maybe kick off a small POC to see if this is a good solution for your organization. Again, easy to point to the cost savings, but you really can't sell short the benefits of really not having to manage infrastructure while also enhancing the infrastructure, right? So if there are no more questions, that is what I wanted to share today. I appreciate everyone taking the time. Cody, I think we are good to go.
All right. Well, Jeff and Siley, thank you both so much for joining us today. I know we did go about a minute over. So to everyone in our audience who's stuck around a couple more minutes, thank you so much. It really does mean the world to us. But Jeff and Siley, thank you both so much for joining us today. I really appreciated everything that you brought to us over the past hour.
Yeah, thank you, Cody. Thanks, Siley.
So before I officially release our audience, just stick with me one more minute. Today's session was recorded, and we will send it to you via email here shortly, but you can also find the recording living on the DevOps website. Just visit devops.com/webinars, and it will be in the on-demand section waiting for you. Just one more reminder to fill out our survey that is pinned to the top of the chat as well as in the handouts. This will make you eligible for our $50 Amazon gift card giveaway. So thank you so much for filling that out. And if you sent in any chats and questions, you are also eligible for that same giveaway. I'd like to thank Spot by NetApp for sponsoring our program today. And to everyone here, thank you so much for attending. We appreciate you spending time with us, and we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, team.
Thanks, everyone.